Hey guys, what's going on? Today we're going to be looking at angles of polygons. So firstly, with the definition of a polygon is a closed plane figure with the following properties. So it is formed by three or more line segments called sides. Okay, and each side, when extended, intersects with exactly two other sides. So this just has you determine if the shapes are polygons. So essentially what we need is a closed figure with sides. That's essentially what we're looking for. So yes, this is a closed figure that has line segments for sides. This is a circle, which we are familiar with that shape, but it is not a polygon. It is closed, but it does not have line segments as sides. Triangle, yes. This is also a yes. This one is no, because again, it is circular or curved. It does not have line segments for sides. And the last one is an open figure, so that is going to be a no. So we can classify polygons by the number of sides that they have. So we're going to look at all these polygons and look at their number of sides, the number of triangles that fit in them, and therefore the sum of their interior angles. So a triangle has three sides, which would be one triangle. And recall that the sum of interior angles of a triangle is 180 degrees. Next, a quadrilateral has four sides. And when you look at the diagonal that's here, that's made up of two triangles. So the sum of interior angles would be 2 times 180, which is 360 degrees. Keep going. So pentagon, five sides. That would be three triangles. 3 times 180 is 540. The hexagon, so that's going to be six sides, four triangles. 4 times 180 is 720 degrees. So if we want to put this in a general sense or in terms of n, okay, call the polygon an entagon. Okay, so that would have n sides. The number of triangles, so we could see the common difference here: 3 to 1, 4 to 2, 5 to 3, 6 to 4. This common distance is the number of sides minus 2. So the number of triangles is n minus 2. So to generate a general formula for the sum of interior triangles, okay, we take the number of triangles we have in that polygon, n minus 2, and multiply by 180, because each triangle has 180 degrees. So our formula is S, where S is the sum, is n minus 2 times 180. And n is going to be our number of sides. Okay, moving on. So polygon interior angles sum theorem. So the sum of the measures of the interior angles of a convex entagon is n minus 2 times 180, which is what we just did. 180 degrees, but you can leave that off if you want. Okay, a corollary, meaning corollary typically just means that a thought or a piece of logic that kind of directly follows from a theorem. So this corollary states that the measure of each interior angle of a regular entagon is, so when we call something a regular polygon, entagon, whatever, that means each interior angle has equal measure. They're all the same thing. So what we're going to do is we're going to take what the sum of the interior angles of this polygon is, which we know to be n minus 2 times 180, right? That's the total amount total amount of degrees inside this polygon. And if we want to distribute them evenly amongst each interior angle, well, then we're going to divide it by n, the number of sides. So that is going to be our formula for that. If we want to know the number of sides given the sum, which basically means we're going to take this formula and just rearrange and solve for n. Okay, so we can do that pretty simply. And it just goes to n equals s over 180 degrees plus 2. To find the number of sides given the exterior angle, okay, we can say that n, or the number of sides, is 360 divided by whatever the exterior angle is. Okay, let's do a couple examples. Let's look at one. Find the sum of interior angles of a 15-agon. So we have 15 sides, n is 15. So then we simply just do s equals n minus 2 times 180. N is 15, so this goes to 13 times 180. And this goes to 2,340 degrees. Okay, what is the measure of each interior angle of a regular 18-agon? Okay, so we can use the formula given. So we're going to take 18, subtract 2, multiply by 180, then divide by our amount of sides, which is 18 in this case. And this is going to go to 16 times 10, because 180 divided by 18 is 10. You can also just put this on the calculator. I just don't have one handy right now. 160 degrees. Okay. Let's also look at number 5, and then we'll move on. So the measure of one interior angle of a regular polygon is 160 degrees. How many sides does it have? Recall that our formula for the number of sides is n equals 360, okay, divided by the measurement of one exterior angle. So they gave us the interior angle of the regular polygon is 160. So how could we find what the exterior measurement is? So we know the interior measurement is 160, but we need the exterior measure. How on God's green earth can we find that? Okay, well, let's imagine this real quick. Let's draw a shape. I'm just going to draw a pentagon. Okay, assume this is regular. I'm not Picasso, so you're going to have to pretend a bit, but pretend that this is just a regular pentagon, right? So a pentagon, okay, the sum of interior angles of a pentagon is going to be 540, okay, and then you can take 540, okay, divided by 5. I'm just doing this for a quick example real quick. So 540 divided by 5 goes to 108, okay? So 10, this interior angle right here is 108, not drawn the scale, okay? So if I wanted to find the exterior angle, well, those lie on a straight line together. So I could just do 180 minus 108, and that could be how I get the exterior angle. So that would make this 72. So similarly here, now you can imagine that these guys are on the same line, the interior and exterior angle, so they should add up to 180. So 180 minus 160, 20 degrees. So we got 360 divided by 20, that goes to 36 over 2, which goes to 18. Okay, that's just a review of all the formulas we just covered. And that is it. Thank you, guys.